ahead to talk about the group differences. Levels of the same population will vary just due to error. Statistical tests are tools that give us information about whether or not those differences occurred by chance, or can be attributed to an independent variable treatment. The techniques are often used for data analysis in experimental and quasi-experimental research. They enable us to evaluate the effects of an independent variable or categorical variable on a dependent variable. Please note that the techniques are not used in isolation to establish cause and effect but only to evaluate the influence of the independent variable. Cause and effect are not established by statistics but by theory, logic, and the total nature of the experimental situation. How statistics test differences. In experimental research, the levels of the independent variable may be established by the researchers. For example, if you want to examine different learning activity on children's motivation, the learning activity will be the independent variable. The purpose of the statistical test is to evaluate the null hypothesis at a specific probability level, for example, p less than 0.05. In other words, do the two levels of treatment differ significantly 5 times out of 100? The statistical test is always of the null hypothesis. All that statistics can do is to reject or fail to reject the null hypothesis. Statistics cannot accept the research hypothesis. Only logic reasoning, good experimental design, and appropriate theorizing can do so. Statistics can determine only when the groups are different, not why they are different. Differences are based on ratios. The t-ratio has a numerator and a denominator. From a theoretical point of view, the numerator is regarded as true variance, or the real difference between the means. The denominator is considered error variance, or variation about the mean. Thus, the t-ratio is t is equal to true variance divided by error variance, whereby true variance is equal to portion of the difference that is real. And error variance is equal to portion of scores that is attributed to subject variability. If no real differences exist between the groups, true variance is error variance, or ratio is equal to 1. When a significant t-ratio is found, we are really saying that true variance exceeds error variance to a significant degree. Comparing two groups, we generally use t-test. In general, there are 3 types of t-test tests between a sample and a population mean: t-test for independent groups, and t-test for dependent groups. T-test between a sample and population mean. We may want to know whether a sample of students differs from a larger population. For example, suppose that for a standardized knowledge test on physical fitness, the mean is 75 for a large population of college freshmen. The population is 1,000. When tested, a fitness class with 30 students that you are teaching has a mean of 80 and a standard deviation of 10. Does your class have significantly more knowledge about physical fitness than does the typical college freshman class? You can use the formula on the slide and do the math. The t-test is a test of null hypothesis, which states that there is no difference between the sample mean and the population mean. M minus mu is 0, m is the sample mean, mu is population mean, s is the standard deviation for the sample mean, n is the number of observation. In this case, t is 2.74, degree of freedom is 29, degree of freedom is used to enter in t-table to determine whether the calculated t is as large as or greater than the table t value. Go to table A5 on page 413, note that across the top of table are probability levels. We want to know whether our t value of 2.74 is significant at p less than 0.05. Read across to the 0.05 level. Read where degree of freedom is 29 row and the 0.05 column intersect. Is the calculate value 2.74 larger than 2.045? Yes. So t is significant at p less than 0.05. Therefore, our sample class is significantly different from the population average on the fitness test. Independent t-test. The most frequently used t-test determines whether two sample means differ reliably from each other. This is called independent t-test. Suppose that we have two training programs at different levels of intensity, 40% or 60% of max oxygen consumption, 30 minutes per day, 3 days per week for 12 weeks. Differ from each other on a measure of cardiorespiratory endurance ran like 12-minute run? The slide shows the formula for two independent samples. Text page 150. Example 9.2 shows how to do the math for this example. T equals 13.81. Check the table A5. The independent t-test is a very common statistical technique in research studies. Sometimes it is the main technique used, and sometimes it is just one of several statistical tests in a study. Below are the issues that you will have to be aware of. Homogeneity of variance. All techniques between groups assume that the variances between the groups are equivalent. Therefore, homogeneity assumption should be checked if group sizes are very different. Meaningfulness of treatments when you use statistics that test differences among groups. You want to establish not only whether the groups are significantly different but also the strength of the association between independent variables and dependent variables. Omega squared is used to estimate the degree of association or percentage variance accounted for between independent variables and dependent variables. Omega squared is similar to R squared for the correlations. Both represent the same idea, which is percentage variance accounted for. For example, in the previous example of 40% and 60% intensity, we really want to know how much of this variation is accounted for by the difference in the two levels of the independent variable 40 versus 60. Effect size is another way of considering the meaningfulness of the differences. Is effect size. Effect size is the standardized difference between two groups and is also used as an estimate of meaningfulness. Some researchers suggest that if there is a control group, then its standard deviation should be used. If there is no control group, then the pooled standard deviation should be used. The standardized value indicating the difference between the means divided by the standard deviation. In other words, it indicates the relative difference. In general, 0.2 is small effect size, 0.5 is moderate effect size, and 0.8 is large effect size. Is called a dependent t-test, which is used when the two groups of scores are related in some manner. Usually the relationship takes one of two forms. 1. Two groups of participants are matched on one or more characteristics and thus are no longer independent. 2. One group of participants is tested twice on the same variable, and the experimenter is interested in the change between the two tests. The slide shows the formula for calculation of t-value. The textbook listed a detailed example in regards to calculation of t-value in this case. Please refer to page 153. Details of the test. When we read table A5, you might wonder why we use two-tailed t-test as opposed to the one-tailed t-test. We used the two-tailed test because we assume that the difference between the two means could favor either mean. Sometimes we might hypothesize that group 1 will be better than group 2 or, at worst, no poorer than group 2. In this case, the test is a one-tailed t-test, that is, it can go only one direction. Then, when looking at table A5 for a one-tailed t-test, the 0.05 level is located in the 0.10 column for the two-tailed t-test.